All right, to anybody out there listening that's named Felice, what's up? All right, x squared plus xy plus 8x plus 8y. Your directions are to factor the polynomial by grouping. So the way that this would be done is we got to figure out, like, is there something that two of these have in common but maybe the other ones don't? Like, I'm looking at these. They both have an 8 in them. These both have an x in them. And this one also has an x in them. But I'm looking for, like, two of them to have something in common. So like I said, these have an 8 in them, so I could separate those and say, all right, let's take out the x, and now I've just factored them. And we've got x plus y in parentheses because you can distribute. The same can be done over here with the x's. X's can be taken out of both of these, so if I did that, it would say x plus y right here, because x times x is x squared, and then x times y is xy. And what you'll notice here is that you've got two of these terms are matching, x plus y and x plus y right here. And so it's no different than when you were learning probably about the distributive property originally, 5 times 6 plus, I don't know, 5 times 4. So I'm just making up numbers, but this will be 30 and this will be 20. And of course that simplifies to 50. You could just skip a step here and say 5 times 10 is 50. And I got that 10 by doing 6 plus the 4, and I kept that 5 the same since that was a factor in both of these. So the thing that's a factor in both of these is x plus y. So similar to what we do over here with the 5s, I'm going to do over here with x plus y. So I'm just going to write that one time. And then what I'm going to do is I'm going to multiply not multiply, but add the x and 8, similar to what we did when we added up here in this example, the 6 and the 4 to get 10. So now I can multiply those together, and if you do the math out now, interestingly enough, let's just multiply these first terms. X times x is x squared. If I multiply this middle term, y times x is y times x, or x times y. If you do x times 8, you'll get x times 8. And then finally, the last terms of each of these binomials, y times 8 is 8 times y. And you notice that's the exact same problem we started with, so therefore this is a good way to factor that. One more I want to show you. This is from the form that I made for Tuesday. So this is a form I made from Tuesday. You can see that we've got an equation now, so they're already grouped for you. But what I can do, I can take out an x squared from both of these. And if I do that, I'm going to be left with x plus this number right here. Since I took that out, it's just going to be 1. Because if I was to multiply x squared by x, that would equal x cubed, which is this number. And if I multiplied x squared by 1, you get that number. And on this side, you can factor out a 4. So we're left with 4 times x plus 1. Once again, if you distribute that 4 times x is 4x. 4 times 1 is 4. So now you can see that they have a common number here that you're multiplying on both parts, x plus 1. Right? You're multiplying 4 by this since you're distributing. And you're multiplying x squared by x plus 1. So what I can do, since I'm multiplying x plus 1, is divide x plus 1 on both sides of the equal sign. So that cancels, and I divide by x plus 1 right here, and this will cancel. So what I'm left with now is an equation that says x squared is the same as 4. Well, if you take the square root of both sides, you'll end up with x equals 2 or negative 2, because negative 2 times negative 2 is 4. So if I plug this back in now to the equation, 2 cubed is 8, right? I'm just substituting 2 for x, plus 2 squared is 4. And then on the other side, 4 times 2 is 8, plus 4. Well, they're the exact same thing. So we can see that 2 would be a valid solution. What about negative 2? Negative 2 times negative 2 is 4, times negative 2 is negative 8. Plus negative 2 times negative 2 is 4. So we've got negative 8 plus 4 on the left. On the right, we're doing 4 times negative 2, which is negative 8. And we're adding 4 again. So both sides equal out to negative 4. So it's a solution that works for both. Hopefully that helps a little bit. Those are the problems that I'm looking to go over today on the remote check-in.